So hello everyone, my name is Carlo McIltrot. I'm the Data Technology Platform Manager at TriState Capital Bank. I'm joined by two of my colleagues, Tommy, who's a solutions architect, and Benji, who's a data architect. Over the past year, we were tasked by the bank with building a data lake to support analytics, reporting, and AI. We were having a lot of issues at the bank with having access to data, not having a centralized location, not knowing how to get into our data, and have a huge project upcoming for the 100 million threshold initiative, which requires more deeper reporting for the Federal Reserve. So that's kind of what drove this whole discussion. So I'm first going to go into kind of what a data lake is and give people a little bit of background on that. I'm going to talk about what we did at TriState for our data lake and what we call the Common Data Platform. And Tommy's going to take it over, talk a little bit about best practices and maybe why you want to implement a data lake or something similar in your organization. And Tommy's going to talk about how you can enable AI over top of your data lake and some of the things that we've worked on internally to give that AI capability to our people and really empower them with data. So to kick it off, first, what is a data lake? I think a lot of people throw out a lot of terms around data, and maybe the people who aren't down in the weeds working on these things, it's not very clear. So first of all, data lake is a single centralized repository of your data. You're no longer going out to set disparate applications in different areas to pull in things that you need. You go to the one-stop shop, it has everything you need from all of your applications and sources. It's going to support all types of data, structured, unstructured, and semi-structured, and that's kind of a little bit of tech speak for things that are organized or unorganized. So say you have something living out in an Excel spreadsheet, that would be like your unstructured data, and a data lake can support all of that, from that all the way up to a highly structured and normalized database. And in your data lake, it'll capture your historical data and keep old data for you. So if you ever need to look back at something happened a long time ago, you'll have that capability there. And the reason why you might want to do some of these things is for analytics. Data is now driving everything that we're doing in today's day and age. And to really power those analytics properly, you need the data to support them. And on top of that, I'm sure everyone's hearing about AI and machine learning, and to really power those models and get the value that you can draw from them, you need some place to feed it, and that place can be your data lake. So a quick little comparison again, just to provide a little context. What's the difference between a database, a data warehouse, and a data lake? I'm not going to read this whole slide to you, that'd be pretty boring, but the high level important thing is that a data lake, again, it allows you that unstructured data support. It really scales with your organization and your level of maturity. So where like a database, it supports a single application, it's highly structured, it needs the format set up front, where a data lake supports what we call schema on read, which means that you don't have to define what something should look like and what the data needs to look like whenever you're pulling it into your data lake. We typically talk in terms of ETL and ELT, which stands for extract, transform, load, or extract, load, transform. And a data lake supports the latter. So you pull the data out of something, you dump it into here, you don't really worry about it, and then whatever you need that data for, you transform it to support that. So it's very highly flexible. As your organization grows, it really likes to grow with you. And it can support a lot of different initiatives that you don't get the same flexibility with the other two types of data stores. So moving on, talking about the Common Data Platform. This is the data lake that we've implemented here at TriState. I'll try to keep this a little bit light on the tech speak. I gave it over to my wife and she called me a nerd. So try to keep it as light as I can. But we built this all in Azure Cloud. The three main cloud providers, Azure, Google, AWS, they all have essentially the same similar type of products. But we went with Azure just because that's what we use at TriState. So our other teams are already heavily integrated into that, and to provide them with the easiest possible access, we went along with that same cloud solution. So a few key parts of that tech stack. The data lake Gen 2 storage, that's Azure's type of data lake storage. It essentially is a real fancy term for just what looks like a Windows file system. So people are really familiar with it, even non-technical people. They can go in there, they can see a folder that's named after your application, and they know exactly what's in there. Gives you really a lot of flexibility by supporting, again, any type of file type, any type of structure, allowing you to just dump everything that you want to in there. We also use function apps, which is essentially small bits of code that are written to do certain things. Primary drivers of that for us are change data capture. So a lot of data systems aren't able to detect their own changes, and sometimes those changes are really important to an organization. Maybe you want to know whenever a customer gets updated or changes their address. These are all things that can help you make better business decisions. So being able to track those changes is something that we thought would add a lot of value across the bank. So we have enabled that through function apps. Another thing we've enabled is a process called tokenization. And tokenization is essentially when you swap the value of a sensitive data point with a randomized data point. So if you have, for example, a social security number, you would swap that for a randomized social security number. And what that does is it protects your data so people don't have access to those true values. And this becomes really important when you start layering AI over top of your data lake, because AI harvests your data, it trains on your data, it pulls your data out, and to protect your data from that, we use the process called tokenization. And Benji's going to talk a little bit more later about the work we've done related to that. We use Data Factory as an orchestrator, and essentially what that means is we use it to kick off processes and schedule things and let people know when things are happening. We took a really highly parameterized approach to this. We set out the goal that someone will be able to onboard a new source into the data lake in one day, and we've accomplished that goal. We actually had a new hire just a few months ago. He had no previous experience with any of this, fresh kid out of college. We kind of dumped this on him and said, hey, can you figure this out in a day? And he was able to do that. So we thought that was a really great win. It allows you to be highly flexible, and again, moving constantly with the business and doing what they need to do with their data. And lastly, the last key technology we adopted is called Synapse. It's sort of like SQL, if anyone's familiar with that. Allows your more tech-savvy business partners to go in and query out their data as they need, so they need something really quick. They don't need to work with the tech team, they can go in and get the data out on their own. So for report writers and people providing analytics, those type of business users, they're empowered to do things that they previously couldn't do before. We also adopted what we call a medallion data architecture. If you look at the diagram over on the right, you can see we have the bronze, silver, and gold layers within the data lake. We also call these raw, refined, and curated. Essentially what this means is that at each level of data, you continually refine and enhance that data so that it provides you with better business capabilities. So your raw data just looks like something that you'd see that developers would use in a database, and your gold data is something that an executive leader can look at a glance and quickly understand and gain value from that data to make quick and effective business decisions. And then on top of that, again, the diagram on the right, you can see we're layering over analytics, reporting, and AI on top of this. So that's really the end goal, the outcome of all this. It's kind of an intermediate that a lot of people don't really get a view into, but the outcomes are tangible and they're visible to the business leaders at the organization. And with that, I think we'll hand it over to Tommy. He's going to talk about why you might want to do this for you.
Sure. So keeping it simple here. Number one is the consolidation of data sources, as Carlo kind of alluded to, just a single source of truth. So in many organizations, you have data sprawl. You have data that's in many different locations and many different formats. This is just a way to consolidate it into one singular place. So again, to Carlo's point, an executive leader can look at it and understand quickly, I understand what this is, where this came from, and what the implications are of using this data. Single source of truth is really a universal buzzword you hear a lot of times when people talk about these types of platforms, but that's been a guiding principle of ours. Going on down, this is something that I'm more passionate about, is the process, so the curation process between bronze, silver, gold. For us tech people, it's raw, refined, and curated. What happens between these layers? What do the layers mean? How do you engage with the teams that are doing this data engineering, making these business decisions? Something as simple as what does a customer mean? These are things that we define in these layers and are a byproduct of these structured environments as well. Along with this is it removes the business logic, from these analysis tools. So if you're in a Power BI, a Tableau, whatever you may be familiar with, instead of building logic into a dashboard and then sending it to someone else, they instead don't have to do that in the tool. Anyone that pulls in a customer and account, you know that they're dealing with the same thing, the same scope, context, level of granularity, which is a problem I know we've observed in our bank anyway, so it seems to solve a problem there and makes our analytics users more effective. Data modeling. So it garners transparency into the source data and how systems interact. It's an accurate reflection of the way these systems exist in reality. If it's a customer relationship management system like we have, lending into how are these accounts populated in these databases that our applications use, you're at least able to track that lineage and understand what the business process is through the data. So it's intended to be an accurate reflection of those items as well. And moving on down here, representative of business practices, kind of alluded to that just now, but in the same context, your business processes, you want them to align with the data that's output. So if it's a source system to a destination, if it's a curated data set that captures one specific line of business or portion of the business, it's something that you can easily do here and is easily replicated and you can share out, again, finding efficiencies there. Maintenance is something that unfortunately we're all probably familiar with. These things take work to build, but they're even harder to maintain over time. There's knowledge gaps, you have tribal knowledge, so along all the best practices and the documentation and stuff that we can aspire to have, modifying these curated data sets and whatnot, the way that our platform is built is to accommodate schema drift as well. So if a source system changes, it's natively created so that it can accept that, we'll say, and then use that moving forward so there's not impact to downstream systems. It doesn't break everything if you add a field to a database, is one way to say it. Data governance, which Benji and Carlo have been more involved in than I have, but it's a very important step here. It helps govern the quality of the data lineage, the data ownership, all these things that are perhaps not the most exciting things in the world, but very important when you really drill into it and need to backtrack data quality issues or whatnot. You can get ahead of it by having an effective data governance strategy like we've implemented. Finally, patching and other updates. I kind of put this in as a plug for the ways of the past. My life, my early career anyways, was riddled with server and database upgrades and stuff, and something always broke. It's remarkable. But in this sense, everything we're doing is serverless for the most part. The function apps, the Azure Data Factory, we're not residing on operating systems and certain versions. It's largely serverless technology that requires minimal maintenance in that regard, unless we update something like a Python version or something of that effect, which fortunately we haven't run into yet, but it minimizes those items, which is taking advantage of the cloud. We can go to the next one if you want. That's a Benji slide.
Oh, okay.
Okay.
Okay, that's cool. I'll scoot over here just to get some visibility. So, thanks guys. What would be a cool presentation about data without AI? Like, it's the new thing. Everybody wants to talk about it. It's cool. It's great. But there are some challenges that people don't really think about when they build AI capabilities into your typical data warehouse, or in this case, a data lakehouse. So, no pun intended. Let's just dive into the lake using AI. The main focus here is what we did when we decided as a bank to build a data lake. Our leadership looked at it. There were conversations around AI. And you talk about what can you bring in-house, LLMs, GPT engines, all these cool conversations. So we decided to take a stab at building a quick POC to kind of understand the things that we have, the level of effort, the key outcomes, and our journey if we decided to embark on it. So pretty much this slide is just about our journey so far, what we did, what we built, what our focus was, and the final outcome of the POC that we created. And I wouldn't want to kind of jump into all the cool AI buzzwords, because they probably have heard it over and over between yesterday and today. But we already had an ADL engine to, like Carlos said, that's where our data lake was built. One of the things that we also had to kind of provision in the process was AI Studio, which kind of facilitates this Azure version of an engine or a driver that kind of facilitates you building LLMs, whether you want to go the GPT route or you want to go the Llama, which is, I believe that's Meta's route. So we have to provision that. And the other thing that we also have to focus on is Azure AI search. We'll put a pin in that because that's key to some of the things and the conversation that has been coming up with AI. At the end of the day, one of the things that we were super focused on was, security, that's data security, the level of effort, and also, where do we go after this POC is done. It doesn't sound great. We ended up shelving the project. We, got a chance to understand the key things that we needed, but we decided not to go to the next stages and the next steps and operationalize it. So the key outcomes of it in all was pretty much kind of baked into the concept of tokenization. One of the things that we realized as a data organization, most importantly a bank that is highly regulated, is the possibility of your data getting into bad actors or your data getting fed into an LLM that is hosted somewhere that you have no idea. The best part that we did not have to overcome was our process is what we call tokenized in memory. So we tokenize our data in memory using Skyflow, and then when we land it, it's already tokenized. No one gets the chance to see any sensitive data. No one gets the chance to know who my name is because it comes out as something random. So we already had that part figured out. It was easy for us to just go feed our data to these LLMs and let's see, what happens, right? Because now we are not overly concerned of who gets enhanced, whose name is out there, and which clients we are kind of reaching their data out there. One reason that I also mentioned that it's great to kind of stick a pin in the whole AI search is RAG. I believe most people probably have heard the whole concept of retrieval augmented generation. It's all this cool thing. It's about how do you make your data not hallucinate, how do you make your data effective, how does the LLM kind of pick up all the important things. And not to go through the whole concept of what is the high-level architecture, but our focus was pretty much building vector databases. So there's something called vector indexing, there's embedding, and what we call the retrieval layer. The prompt engineering kind of explains itself. The more you ask good questions, the AI gives you great feedback. But the retrieval layer was something that we focused on because that's where Azure AI search comes into play. You get the chance to actually index your data. You get a chance to build a semantic layer into your embedding models, and then you finally have your Azure, AI search, which is your retrieval layer that improves your queries and improves your timing, and it was perfect for our use case, right? We have loans across multiple people. We have equipment finance. We have our data literally all over the place. But building that layer makes it easier for you to create boxed information that is indexed, and then you improve your retrieval process, which also again helps reduce hallucinations, improves accuracy, and all of that. The final thing that we also picked up was AI governance. It actually put me on the path where I ended up buying a book to read about it. Probably read like 20 pages out of 500 pages, and I was like, this is boring, I'm done. But the key thing was with AI governance, one of the things you have to understand that there is bias, data bias. It's right out there. There is the possibility of data drift. Your sources of data might change over time. The schema drift happens. You have to pay attention to all of that. So the whole concept of AI governance is something that I still think across the entire AI world, we are still familiarizing ourselves. We are building tools. There is Microsoft's Fairlane. But for a bank, one of the things that we decided that in an event-oriented future, we decided to take on these steps. We have to focus on what we came to term as IRBs, that's internal review boards. Like these group of people or this group of brains will sit in a room, try and build some internal governance for our AI so that we don't have the possibility of data drifting and then hallucinations and all those things that we don't want. We don't want to build any bias in our data, again, banking data, so it makes it a little bit tricky. The last thing was model monitoring with explainability. There are multiple tools out there. I think one that is really kind of gaining traction is Shapely. They are your typical coming third party. Microsoft is also trying to get in the game, but come in and help you, or I would say help train your data, that your data doesn't get into a position where, again, data bias is pretty much the biggest thing, where zip codes and account numbers and all of that can make your data actually not act the way that you want it to act. And that was one of the things that we picked up. I believe that's all, but to wrap it all up, it was a great project. POC had a lot of fun with it. Did not have enough data experience, AI experience in the process, but I had a blast. And guess what? The screen is gone. So yeah. How about that? How did you end an amazing presentation? The screen gone. Yeah. But yeah, the next thing is we have 80 questions out there.
Any challenges with data normalization?
Yeah, he's the brain, so obviously.
Yeah, that's actually a huge.
And what did you do about it?
Yeah, that's a huge problem you're running into, right? And there's kind of from two perspectives. One, from the tech perspective of data not being properly normalized so you can't relate it. And two, from the business perspective of two people are talking about the same thing, but they don't realize that they are because they look at different views of that data, right? So we did actually kick off like a kind of like cross-functional project where we were working with all these different data teams. We brought in representatives from the finance department, from operations, and from all these different groups, and we really sat down and said, what is important about the data to you? Identify all of those, and then took those back and built a normalized model that supports all that with common definitions, and essentially a whole book of definitions for the data lake so that everyone is looking at the same normalized view of data. And we're finding that that's really driving better conversations with the business, because whenever somebody says loan and someone says tranche, and those really mean the same thing, but they're saying different words, there's a level of confusion that we've started to eliminate through that normalization.
Is your company acquisitive? Do you make acquisitions?
No, we do not.
Okay. Thank you.
How does adding AI to the lake affect it as far as training data or any data related to the AI being stored in the lake, or changing the structure of data in the lake by the AI, so its presence in the lake itself, the footprint it takes up, and if you are allowing it to make modifications to the lake, so how does that work? Is the AI in a separate space, or what happens?
Yes, so that's a very good question, which I actually failed to pinpoint. So Microsoft's Open AI Studio supports, CSVs, text, JSON, and a handful, right? And we store our data in what we call Delta Parquets. Open AI doesn't support Delta Parquets. So thanks to Carlo and team, they had to create a location for us where it was kind of titled, I don't know, POC, AI POC or something, where it's still in our data lake, different folder like Carlo mentioned. Our data lake is like your typical file system, right? So created that folder for us in the data lake, labeled it, but the process was we had to change all our files that we use for the POC into JSONs, and in the process, when you want to use Azure AI Studio, you have to chunk up the data. So if you have 500 records and you write that into JSON, you have to probably chunk it up into 50 records into 10 different files. So yeah, we did have to make some transformations, kind of go away from how we had built our data lake to support this. So yeah, in the process, and we did this like a year ago. I do not know whether Azure has made new modifications to the type of data that you can feed in, but JSON was what we went to, and then we ended up making those file changes or modifications into
Yeah, and as far as like the AI's capability to actually like modify that data specifically though, we purely did it on retrieval to give people more power to find data, but we weren't allowing it to make modifications to data. Just because of it being in its infancy and wanting to make sure that it's not changing some customer account information and improperly reflecting it, right? But we did want people to have the ability to say, hey, what's the history of all these customers' accounts and how do we pull that data back?
You're talking about the use of AI for the data. May have mentioned. Did you use it to AI to search or look at the internet to learn how to do the things you were doing, and or did you use it to look at your data at TriState and say what are trends or answer questions?
Yeah, so we're primarily looking at the latter, right? I think when a lot of people think about AI, they think about, hey, I'm going to go ask ChatGPT a question, and it's going to go pull off the internet or pull off some publicly available database and pull data back. What that doesn't give you is the ability to have it analyze your own data, which is what this provided. So it's actually looking at our data specifically. It's an isolated LLM that's running on top of the data lake and able to pull our data back. So before this, like whenever someone asks a question about an account, they copy some account information, drop it in ChatGPT. And obviously being a bank, highly regulated industry, very sensitive information, leaking that data out and not knowing where it goes, that's a problem, right? So whenever you have your own isolated data store to put the LLM on top of, you can have it give you that level of granularity with your data where it's specific to you and not specific to whatever it found in its Google search, but keeping that safe at the same time. So, wrap it up. Thank you guys for listening. Very much appreciate you.